5.1 Basic Concepts of Probability, Video 5. In the last video, I kind of shook things up a little bit when I said if you flip a coin twice, will you always get exactly one head? Because we think that the probability of getting heads when we flip a coin is 50%. The answer is sometimes, but sometimes you won't. So how can we justify saying that the probability of getting heads is 50% if when we flip two coins, we don't always get heads exactly once? And the answer is something called the law of large numbers. A probability doesn't describe what's going to happen exactly within a short time frame. It describes what's going to happen over the course of time. The law of large numbers says the longer you repeat an experiment, the closer the percent of times an event occurs gets to its probability. Well, what does that mean in terms of flipping a coin? That means if we were to keep track of flipping a coin repeatedly, at some points in time, the fraction of heads may or may not be 1/2. But if we repeat the experiment over and over, that probability is going to get closer and closer to 1/2. I have a coin here. I'm going to flip it a few times. Tails, heads, tails, tails. So I just repeated the experiment, flip a coin 4 times, and this is what I got. Tails, tails, heads, and tails. Now, what fraction of those are heads? Well, it's only 1/4. Let's flip it another 4 times. Tails, heads, tails, 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 heads, tails, tails. I promise you this coin is not rigged. Now, looking at all 8 of them, what fraction of those are heads? Well, 2 out of 8, which is the same as 1/4. Let's keep track of these as decimals so we don't have to worry about reducing fractions. So after the first 4 coin flips, 25% of the time, 1/4, it came out heads. After 8 coin flips, it was still 25%. But let's see what happens if we flip it 4 more times. Hopefully we'll get some more heads here, but there's no guarantee. Tails. Heads, there we go. Heads. Tails. Tails, heads, heads, tails. Okay, within this 4 coin flips, we did get exactly 50% heads, but look at all 12, which is we're keeping a running total as we repeat this experiment over and over. Out of the 12 coin flips, we currently have 1, 2, 3, 4 heads. 4 out of 12 reduces to 1/3, and as a decimal rounded to 2 places, 1/3 is 0.33. It's still not a half, but it's closer than it used to be. Let's do it 4 more times. Heads, 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 looks like heads are making a comeback. Tails. Heads, 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 tails. Now let's see what fraction of the time heads came up. Now we've got 16 coin flips, and there are 1, 2, 3, 4, 5, 6, 7. That's almost a half. It's just a little shy from a half. 1 more, and it would have been exactly 1/2. 7 divided by 16 to 2 decimal places is about 0.44. And that's what the law of large numbers is saying. If we were to keep flipping coins over and over again, and we don't have to flip them 4 at a time, we can flip them once or 10 or 100 at a time, doesn't really matter, then the fraction of the time that heads came up is getting closer and closer to the true probability, which is 50%. So as the number of flips increases, the percent of times we get heads approaches 50%. Now, sometimes it'll hit 50%. If this last tail had been head, it would have been 8 out of 16, which was exactly 50%. But in the long term, this will fluctuate up and down, and it'll start getting closer and closer and closer to 50%. In fact, if you were to repeat this 10, 20, or 50,000 times, it would get so close to 50% that one coin would barely budge it from 50%. All right, so the law of large numbers basically says if you repeat an experiment over and over and over, the percent of times that the event will occur approaches its true probability.